Welcome to my channel. Your tutor Mariam is here. It's a third video of Introductory Physics 1. In this video, I'm going to solve challenge problems for measurement, which is a first chapter of Introductory Physics 1. I'm really hoping solving these problems help you to understand the subjects better and get the good grades in your exam, as I'm about to tell you a couple of tricks to solve the problems and also the common mistake a student make. So if you're new to Introductory Physics 1, I highly recommend you to hit the subscribe button. Also, I would appreciate it if you hit the like button too and support my channel. It just encourages me to make more videos. You ready? Let's get started. Alright, challenge question 1. A car is traveling at 30 meters per second, determines its speed in miles per hour. As a quick reminder, in the video 1 and 2, I talk about the property in physics. We have the different properties like a distance, mass, time in physics, and they come with their own units and symbol. Like for the distance, unit gonna be meters, and symbol is little m, time gonna be second, and then symbol is little s, okay? And also I talk about the conversion factor, like you can use them to convert units. For example, for kilometers, 1 kilometers is equal to 1000 meters, and also 1 grams is equal to 1000 milligram, and so on and so forth. You can find these conversion factors in your textbook, and also you can look it up online. Let's look it up online and see the equation for this, or I would say the conversion factor for our problem, question 1. So what I'm gonna do here is look for mile to meter, right? And then I can see the conversion factor here. 1 mile is equal to 1609.34, right? So I can use this conversion factor to solve the problem. If you don't have your textbook, you can always Google it and use this equation. But my point here is to show you how to apply this conversion factor to your problem. Now let's look at the problem. Okay, let me remind you 2 rules that I made up in the previous video to help you to solve these problems better. So the first one is only same unit cancel out, and the second one is units don't appear or disappear. So what I mean by that, here I have 30 minutes per second, right? And we just find out that 1 mile is equal to 1609 meters, right? The other way I can write this equation or conversion factor is say 1 mile only use the symbol. It's gonna be faster to write, and meters, right? So here I just use the symbol instead of writing down the mile and meters, right? So I have 30 meter per second is gonna be times of a fraction. So let me draw my fraction line. So something should be in numerator and denominator, right? How can I write it? Let's look at the first rule. Only same unit cancel out. In order to be cancelled, one should be in numerator and the other one in denominator, right? So if I put meters in denominator, then I can tell, okay, meters gonna be cancelled with meters on top here, right? So meters, and then I'm gonna write down mile on top, right? So based on this conversion factor here, I know 1 mile is equal to 1609, right? So what I just did is like I convert the meter to mile, right? So this is about the conversion of length. However, I still need to work on second and convert second to hours. We all know 1 hour is equal to 16 minutes, right? And then 1 minute is equal to 16 seconds, correct? So here, let me change the color. Right. And then times. So now I'm gonna work with time here. So what I'm gonna ended up is having hours. So 1 second, let's start with this because I'm gonna convert second to minutes and then minutes to hours. So here this second should cancel out, so it should be in nominator, and then I'm gonna use this one first, right? So minutes gonna be in denominator. So 1 minute is equal to 1660 seconds, correct? Times, so I know second and second gonna cancel out, right? But my question asks for hour, right? So now I should convert minute to hour. Again, fraction line is gonna be minute gonna be canceled out, so it must be in nominator and then hour. So 1 hour is equal to minute 1660 minutes, right? Here. So now minutes and minutes cancel out and I can have hours. So here this is for converting time in hour, correct? So what I have here is like 30 times 60 times 60 divided by 1609. Let's look at the units I have. This is what I mean by unit don't appear or disappear. So you must consider all units you have. In nominator, the only units left is mile, right? In denominator, the only things haven't canceled out yet is hours right here. So if you do this with a calculator, you're gonna end up with the answer, right? And your unit's gonna be mile per hour, right? So the answer gonna be 67.1 mile per hours, which is B. Challenge question 2. Density is the substance mass per unit of volume. Which of the following gives the correct SI unit for density? So density symbol is rho, but if you don't know what is a symbol, you can also show it as an X. So it's like an unknown parameter. Doesn't matter here. It says it's gonna be mass. We know the symbol is M for mass, and volume symbol gonna be V, right? But we know for mass there are different units as kilograms, grams, pounds, right? And also for volume, which is a product of three length symbol is L, So it's like a product of three lengths, L, 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 right? Also, it can come up with a different units. So let's talk about the centimeter first. So the first length unit's gonna be centimeter times centimeter times centimeter, right? So, and then it's gonna be cube centimeters, right? But in this problem is ask for the SI units, right? So we know for the mass, SI units is kilograms here. And for length, SI unit is meter, right? So instead of having the centimeter, it's gonna be meter. Now it's gonna be cube meters, right? Which is the C. Let's look at the last challenge question. Okay, challenge question 3. A box has a mass of 6 gram and a volume of 3 cube centimeter. Calculate the density of the box in SI unit. Density is the substance mass per unit of volume, right? So we just solved that problem. Density is equal to M over V. And then my mass here is 6 gram, right? And then volume is 3 centimeter to the third. So 6 over 3 gonna be 2 gram per centimeter to the third, right? So my answer gonna be A, right? No. Why not? Because look at the problem is ask for the SI unit, right? So mass unit in SI unit gonna be kilograms and volume gonna be meter. So here I have to do the conversion, right? So how I'm gonna do that? We already know 1 kilogram is equal to 1000 gram, right? This is my first conversion factor. And the second one is 1 meter is equal to 100 centimeter, right? This is two conversion factor I already know, correct? Let me change this. So now I'm gonna do the conversion. So my mass gonna be 2 gram per cube centimeter, right? Times, I have to write a fraction here. So first, I'm going to do the conversion for mass. I know 1 gram and kilogram. Why I put the gram in denominator? Because I have to do the conversion in the way that grams can be cancelled. So this gram gonna be cancelled with grams here, right? So I know 1 kilogram equal to 1000 gram, right? So this is for mass. I just did the mass, right? Times. Now this is a time to do the conversion for length. So here I have 1 meter. So meter should be in denominator and centimeter should be on top, right? Because I want cancel this centimeter to centimeter. What I want you to notice here, I wrote 1 meter to centimeter, right? That's a conversion factor for meter. However, here I have cube centimeter, right? So how I'm gonna do that? This is like a product of three lengths, right? So 1 meter cube gonna be 100 times 100 times 100, right? Which is equal 10 to the 6 cube meter, centimeter, sorry, right? This is how I can write it. So based on this, now I have 1 meter equal to 10 to the 6 cube centimeter, right? So now this centimeter cancel out with this one. So what I have is 2 times 10 to the 6 divided by 1000. Now let's look at the units. In nominator, I have kilograms, and in denominator, I have cubic meter, right? So my answer gonna be 2000 kilograms per meter to the third, right? So this is not a right answer, right? So my answer gonna be C. All right, let's talk about what I just did. I had a box with 2 gram per cube centimeter, and I converted to kilogram per meter, right? In the previous video, I talked about the conversion unit and why we are doing this. So the reason is I want to tell people what I have. If I think about a box with a gram and the dimension is centimeter, what come to my mind is like, okay, that must be a very small box, right? Because the units are in centimeter and grams, so it must be small and light, right? But if I think about a kilogram and meters, it must be a huge box, right? So this is what I did. We convert 2 gram per cube centimeter to kilograms per meters, right? So I'm not talking about a small box. I'm talking about a big box, and this is heavy, right? If I think about the dimension as a kilogram to meters. That's what I meant in the previous video. Like, I want to tell people what I have. So I remember when I did my undergrad, I made this mistake. I was like, okay, gram to centimeter are gonna be very small and very light, but no, it's not. If you think about the SI units, which is a kilogram per meters, this is not a small box. We're talking about the big box, and this is heavy. It is 2000 kilogram per cube meters. All right, I thought it's worth to mention here. Hopefully you enjoyed this video. If you like my videos, please hit the like button, and I'll see you in the next video.